Hello everyone. It's early Sunday morning, so I guess you're all very interested in these open source tools for water resource management. But just to know who I'm talking to, can you please raise your hand if you are a water resource manager or have a background in water resources? Not too much. Okay, I thought so. So I prepared a very short introduction in water resource management because it's very important that you know the background for some choices that these tools made. So hydrogeology, it's part of water resource management, and it deals with the study for groundwater and groundwater flow and related issues. And as we know it today, it started about 200 years ago, a bit less, with an engineer called Darcy, who came up with the idea that groundwater flows from high to low pressure following a certain constant here, this K in his equation, which is called hydraulic conductivity. And it's a value related to properties of the soil, like porosity and grain size, etc. And so, okay, he had in his time some monitoring wells where he could examine water pressure to get a grip on water flowing through the subsoil. And in one dimension, of course, this equation is very easy to solve. But groundwater flows in 3 dimensions, so other people put effort in simulating groundwater flow in 3 dimensions. For this, there are several options to take, but I think the most well-known package today, ModFlow, discretizes the subsoil in blocks, and then this equation in 3 dimensions is solved for each block. Solving this equation is not very straightforward, but there are a lot of tips and tricks, etc. And there are solvers today available that are also open source. But of course, the most important thing is not that you are able to solve an equation for a numerical model, because that's just an approximation of the real world. You have to go back to your data, because that's what you're actually working with. And so looking back to this data from Darcy, you have monitoring wells, which is simply XY coordinates, a set for depth, and a value related to it. And then you have some properties of the subsoil. If you're lucky, you have properties for different layers. And you can put these in your equation. And nowadays, of course, you have a lot more data. You really have plenty of data. You have to choose between the data. And normally, I think most people use a GIS system to group all the data and build your conceptual model. Your conceptual model is something you think describes the groundwater flow for your purpose the best way possible. And then usual practice is that you do that in a GIS and you take those results and insert them in a graphical user interface that solves this equation. You build a numerical model in a different software. There are some softwares available that can do both, but in my daily practice we have to switch. And that's what this tool is very nice, is that it integrates both the GIS and the solver. So this is the FREEWAT project. It is a Horizon 2020 project. And its main idea was to provide an open source public domain GIS integrated modeling platform to promote this scientifically approach to participate with all actors from an early stage. So everyone can look at the GIS and tell something about it. Not everyone can look at a numerical model. So if you use this GIS in an integrated way, you can get better interaction with everyone. And of course, also it's open source. So the project leader, one of his ideas is to move money from license to human capital, which I think is very nice. It's developed as a QGIS plugin. They chose QGIS because it already provides a lot of options or other modules that are used in this plugin. For example, you have the Spatialite database where all the data are stored. And through the Python interface, use is made of this FlowPy library, which is an interface to this ModFlow model of the USGS. And then several tools were developed to work with your GIS data and your mod flow data. This is a bit of a flowchart of the different modules that were developed in FREEWAT. It's quite a lot. I will be very short because I don't have very much time, but I will show you where you can find more information on the web. So you have one is the ACFA GIS. It's something for chemical data storage and data analysis. You have the observation analysis tool, which is more related to time series. Then you of course have GIS tools integrated in QGIS. You have the tools related to the mod flow part. There is also an integration with the calibration and sensitivity tool, and of course some visualization. In the next slides, I will briefly introduce some modules. I didn't prepare a live demo because, I didn't know I was going to be able to, and I also have not very good experience with live demos actually. So it's print screens. So I'm sorry for those who were waiting for a live demo. Anyway, you can find it on the web. This is a print screen of this ACFA GIS part. So you have the FREEWAT tool. It's in your menu bar here. The first one is ACFA GIS, which is composed of several subsets. You have one for database management. Then there are several options for a hydrochemical analysis of your data and also a hydrogeological analysis of the data. So this is more related to chemical data, and this is more related to your water pressures, etc. I will not go into detail how all the data are inserted and you can manage them. It's all nicely done. Just show you some outputs that you can easily obtain with the data. So for example, you can get a visual representation of your sodium absorption ratio. You can make a Piper plot. And then here, this one I even didn't know about. You can get a lot of results, and actually all these results you can use to look at your hydrochemical properties of your groundwater and discern which groundwater sample differs from another one, to get an idea of how groundwater flows between wells, if it's from a different origin, yes or no. So these are the simple plots, and this is actually a 2D map where you have the same, where you visualize the difference on a map, where you get these results here, and this one is enlarged then, where you have differences in, what is it, sodium, magnesium, here the cations and the anions, and that way you can get on a map a view of the differences between groundwater in your domain. So that's for ACFA GIS, already a nice outcome. This is for the observation analysis tool, where you have on the one hand options to gather data from sensors, insert them also in your database. That's this one. You can then easily export the data from the database to your mod flow model to use as observed heads, and then in the output you can get here the what is the observed? I think this one was the simulated, and this one is the observed heads at that monitoring well. So this is also very nice to have a very direct link between your monitoring data and your model output. And of course you can use QGIS itself to make nice maps, etc. Of your results. The main part of this FREEWAT tool is of course the modeling with ModFlow itself. This is the, you have, so here you can see it a little bit. Maybe you have different options you have to fill in. I guess people who have already worked with a ModFlow GUI know that you have to insert a lot of data. And this one is related to the packages that your solver needs. So you can choose to model or to simulate groundwater flow. You can also do solute transport or heat transport. There is also an option for water management. So this is more related to agricultural practices and how water budgets close for your entire system. And of course also this model calibration at the end. But this I will not, the last two I will not go into detail. So it uses Modflow 2005. You can select the desired packages here, insert some solver parameters, and it's the usual Modflow stuff. And then you press run, and hopefully it converges. And then you get some results. Here I show one result for pumping wells next to a river, where you this is the flow paths that are visualized, where you can even, I don't think I included that as a slide, but you can also give a color to the different to the time it took for a particle to reach that well, so you can even increase the visual representation. Then one final thing I wanted to show about the modeling part is this one. So you see here, this is actually it's not including the other one, but you see here the discretization of the domain, which is of course necessary for Modflow. And this is a heat transport model where you inject heat and you extract water here. And this is a lower permeability zone. And so you get the usual, people familiar with Modflow, this is a usual output you get from a Modflow file. So that's all possible here now in QGIS itself. But of course, where is FREEWAT now? Maybe for the record, I didn't state I was not part of the FREEWAT project. I got included at a later stage as a beta tester. So I'm speaking for FREEWAT, but I'm not part of the project. That being said, where is FREEWAT now? So there are a lot of stakeholders involved. I heard more than 500. There is a LinkedIn group. There is some Twitter going on. And this is already from a time ago, but there are more than 3,000 downloads of the software. So now it will be even more, I don't know. And it's quite diverse. It's of course it was a European project, so most of the downloads are in Europe. But you see that every continent is a bit represented, so you have a quite diverse user group. And also the purposes for which people indicate they will be using this package. It's mostly research, but there's also training, consulting, and then some other purposes also. But so you have a diverse user group and also a diverse. It's used in various cases. So it will be very interesting to get to know the use cases of all these persons to even improve the tool later on. And now actually I'm giving this talk hoping to persuade some people to join FREEWAT. If you're interested, you can download the code from various places. I will explain later, but I think the most interesting one is this one. It's the FREEWAT website, where you have to fill in why you will be using it. It's nice for the people from FREEWAT to know their users, but also for you. If you do it this way, you can get access to the manuals and the tutorials that come to the download also. There are some Google groups for talking about users, application, bug reporting, and also for developers. And of course, for developers, if you would like to have direct access to the code, it's hosted on GitLab. So this is the main access to the code itself. And so I encourage everyone to have a look and maybe add some new stuff or make some corrections, because it was a project that's a continuation of previous projects, so it carries along some history. And also, when development started, it was still QGIS 2. And also it's developed in Python 2. Now QGIS is going forward to 3. So this tool will also need to be translated to Python 3 or converted to Python 3. And there are also some other issues that could be ameliorated. For example, your computational grids can use some advanced features. something about database interaction, etc. I will not go all into detail. And of course, docs and unit tests, it's always a bit late to add. And then if you have a look at the code, of course, you are very welcome to add IDs you have concerning these tools, or of course, develop them yourself. So the project, I don't remember if it already finished or is finishing, but of course we are hoping that it will continue. We are now actively developing, or there is a community present, but we would like to have as much people involved as possible. And therefore, this talk was mainly aimed at you guys to join FREEWAT and make its development even progress further and faster in the near future, I hope. And with that, I'd like to thank you for being here this early, and I hope to hear a lot of very interesting questions. Okay, so the question was how large the area is how large is the area that you can model, and that strongly depends on your discretization. So you can choose the entire world, but the number of blocks you can put in your model is currently limited. That was what I said about this grid architecture. It's rather limited. It comes from a GIS background, sort of, I guess. So in commercial packages or others, you can include millions of cells. In FREEWAT, not. You can only include a few thousands. So if you want to model the entire world, you will be very limited, and you will have a block size of Belgium, for example. If that's okay for you, it's no problem. But that's one of the aspects, I think, that really requires further development. So I hope that answers your question. Okay.
The question is yeah, put the focus on this for all the coders and so on, so that people can mind it.
Okay.
It's a huge issue.
Okay. So indeed, I would advise you can put the issue on GitLab issue, and then you or someone else who has the same can add it
It's
in
a cool
this.
more than the question.
Yeah, yeah, indeed. Okay. Yes.
How is it licensed and when you compile it?
Okay, about the compiling, that I cannot answer. It's licensed under the GPL version 2. And compiling, sorry. But, yeah. Yes? No, indeed, you're right. There are courses being given in this project even. So the tutorials that you find online, they provide material for teachers to use in their courses, and there are courses being given with those tutorials from people of the project in Spain, Italy, I think in the Netherlands also. I'm not sure. But so it's possible, yes, of course, and it's available online. Okay, no further questions. Thank you.